This is Jim Bob. Jim Bob has an idea for a new tech startup. He's gonna make Photoshop CS65 as a web app. He's convinced that this is just what the world needs. He's gonna disrupt the entire industry. This is an explosion. Just imagine that this is like, yes, I am a beautiful at drawing. I am an artist. Okay. Yeah, so he's gonna disrupt the entire industry. He's gonna gain a large social media following. He's gonna make bank, and life will be beautiful. Let's get rid of all this. So he has an idea. He gets to start working on that idea. He starts coding it, all right? And he successfully makes it to his alpha release after months and months of constant, like 24/7, being on the grind, working late nights, working late days, afternoons. This dude is like just working every waking second, bro. And what he does then is like he launches his product to his users, right? And when that happens, your product sucks. I can't undo. Yeah, Jim Bob forgot to add like undo redo functionality in his product, like Photoshop CS65. You see how I can just press Control Z and that disappears. Yeah, Jim Bob doesn't. He didn't plan for that, man. And now Jim Bob is stuck. Jim Bob makes a last ditch attempt to take his game state and make it an array. So on every action, you just make a new game state. And this way you can undo or redo. But that just takes too much RAM, man. It crashes his user's application. Windows just labels it as a virus at this point. It's not working out for Jim Bob. Okay, so the idea is your app is supposed to function around the concept of commands. What is a command? A command is something that takes in some data and either does an action or does the reverse of that action, which is usually called execute or an execute. It's also helpful in some cases for your command to serialize or deserialize or unserialize that data. If you don't know what serialize is, it's just taking your data in memory like a JavaScript object and turning it into string like json.stringify, and this would be json.parse. The purpose being you want to send it to a server and receive it from. So it's pretty helpful to have these two things here. So all of these things in entirety like make a command. A command gets some data. It can either serialize it, deserialize a string or whatever comes in into that data, and it can do an action or the reverse of that action. To make this whole thing work, you're gonna have a command system, and it's gonna save all of the necessary data of all the commands that you fire in a list or something, and then it's easy for you to just take any of these data here and in order just do the reverse of whatever action was made. And since each of these individual commands or like the data for those commands are fairly lightweight, you don't have like a memory problem, and it gets fairly easier to like store as well. Also, you can just take all of the commands and play them back from front to the end to reach the final state of your app instead of just saving the state again and again. So all you need to function are these commands or the data that they use. So this is how a command should look, the interface of a command. It should have like a name that uniquely identifies that command. It would have the execute and unexecute that would take the data and do something with it, namely an action and the reverse of that action, the serialize, the deserialize. So for example, if we were to make a command that would just set the value of this variable g, it would be like, it would have a name, set g, and it would execute and unexecute on some data. That data would look like the next number that you want it to be and the previous or the current number that it is, right? So that way execute can just set it to the next value, and when that data gets stored, it can reverse that action to make it have the previous or the original value. Serialize and deserialize are just fairly simple. It's just JSON stringify and parse. And yeah, so let's take a look at how we're gonna manage all of the commands. So part of managing the commands is saving all of the fired commands in a list somewhere so we can later go fetch it if we need to undo or redo things. So let's design a system specifically for that. This does nothing except just store our history and give us the data that we want, whether if we want to undo or redo. So an element of this needs to uniquely identify the pieces of a command that we need to perfectly replicate it to execute or unexecute. So it would be the command's name, the data that that command ran with, and the direction that it ran in. So whenever we fire a command, we need to just record it. And if we need to undo, we're gonna take the last command from the history, we just pop it and push it into the redo stack if you want to redo that later, and then just get that data. That's why whenever we record a command or when we do a thing, we're gonna set the redo stack to just an empty list, because the future has been changed, there's a new command. And get redo is just, we just pop from the redo stack and get that command. So this just manages the history and the undo redo bookkeeping aspect of the command system. Let's look at how the flow of this is supposed to go. You're supposed to like make a command and then make the command system and then register that command with the command system, and you're done with the command. You're never actually gonna use that command ever again. You're always just gonna pass the name of that command that you registered and the data that you wanted to work with to the command system directly. You never ever invoke the command directly, either execute, unexecute, whatever. So once it's been registered, you're done. You use the command system from then on. You do the thing on serialized data, and you can undo, redo, whatever. All right, so the first thing our command system needs to be able to do is store all of the commands so that we can refer to them by name whenever we want to invoke them. So for that purpose, we have just an object, a mapping that keeps track of all the commands, and we can use that using the register command function, which is storing that command by name. And we need to bookkeep all of the history of the commands that we're going through, and so we have a transaction system that we just talked about a bit earlier. Keeping these aside, a more general dispatch function would be we give the name of the command, we give the data it's supposed to work with, or the serialized form of that data, we give the direction we want to go, either forwards or backwards, and we choose whether we want to record that command or not in our transaction system. The implementation of that looks like we just do a few checks. Is the command registered? If not, we need to register it first. Just deserialize if any serialized data is present. We record if the flag is set to true, and then if the direction was forward, we execute, otherwise we unexecute, and it's not supposed to be anything else, so we just throw an error. So this is a general dispatch function which we don't want to expose, because we don't want external things to control the direction and whether the thing will be recorded or not, because we just want them to do these three things: do, undo, and redo. So do is fairly simple. It's literally just dispatch. Undo is we get the transaction data from our transaction system. If there's no data, we return. Otherwise, we dispatch with the name and data and the opposite direction. And false is like we don't want to record that because it's an undo thing, our transaction system already took care of the bookkeeping. For redo, it's like, again, we get the transaction. If no transaction, we return. We take the name, the data, and the direction, and yeah, just dispatch that. That is the entire command system, composed of a command system, and a transaction system for bookkeeping. Now let's try to run all of this to just see it in action. And we can see at the start the G value was 9.8, and then it becomes 12, and then it becomes 15 from the serialized data, and we undo, it's back to 12 again, we redo, it's 15, and then we undo, it's 12, and then we undo, it's 9.8 again. So like this works flawlessly, and this is like a very basic implementation of a command system. There's extra things that you can do, for example, like have start and end methods to your transaction system, so that you can have a bunch of commands between start and end, and you can undo or redo all of that at once. That's an additional thing that you could do. And in regards to collaboration, we can have like a server, and whatever commands this computer is doing, we just send them to a server via a WebSocket, and other computers can receive the same command and run it as is. So this is further helped by the implementation of our command system that can just run fine with serialized data, and that is why we actually try to keep all of the data of all of the commands serializable, so that we can have this benefit. So yeah, you can do a bunch of things, you can play around with it, but just that basic system goes a long way. All right, then I'll leave y'all to your new revolutionary Photoshop CS66 implementations, and yeah, I'm out.